let's continue. Let's work on the last part. It's empirical study. Okay, so we have done, yeah, we don't need to do table 3. So we should get table 4 from running the following code. Okay, so the first several lines are just definitions for the variables, and you can, after you run this part, and you should get the results. Let's give it a try. Yeah, so you see, this is the definitions of the variables, and also you see the variable labels. It shows how it is calculated. Okay, so and if you see, like, it is displayed here, so you can copy and paste to Excel and Word file. Anyhow, so this is this part. So the logout is not working, like in my version here, and the table stat will report the means and standard deviation and all these. This is table 4. This is table 4. Let's run this one. So this is a description. So it shows all the variables, its definitions, and the labels. And if we run this one, so we should get the results. Yeah. So this is table 4. So you see all these number of years listed, the age of the CEO. You can see all these variables. We got 9,328 firms, and its mean standard deviation. And of course, you can add. You can calculate more under here to get more informations here. But anyhow, you can copy and paste to get table 4 from here. Okay, so the next one, we want to calculate table 5. We want to calculate the correlations of the variables. To do that, the original code is using PWCOAA-RR-A here, and the PWCOR correlation here. This comes with this data, but this one, I think it's created by the users. Maybe we can find it. Let's see. Yeah, it is, but I didn't do that. But we can, oh, no match. Okay, but anyhow, it could be in the newly added do files, but I didn't check that one. But anyhow, to get the correlation matrix, PWCOR is also working. It shows significance. This is significant. This shows significant at that level. Okay, so the original file is using this command, but you can try with the additional newly added do files. It could work. It's created by the users. Okay, so after running this one, and let's give it a try. Okay. This is a correlation matrix. So you see, it's all under 0.5. If it's above 0.5, it could be some problems, but it's not. And of course, IRA and IROA and all these are highly correlated, so it's not a big issue here. So so for the other variables, there's no correlation problems here, because we didn't find anything above 0.5. there's another way to do to check the correlation is to check the VIF. To check the VIF here. Yeah. So it's over here. It gives the descriptions for this variable. And if VIF was less than 10, and A should be fine. And the correlation is not a problem. But if it's greater than 10, then that's an issue you should address. Okay, so this is the way to do that. QUI is quietly, means quietly. It's running regressions of ROA over here. Okay, and it's just running, our VIF is just running using one of the control variables as dependent variable and run that on the other variables. That's what this one, run the regression of ROA on other variables. And then it's, I forgot the details how to calculate the VIF, but it's just run, it's based on the regression results. So we can run this part. So VIF is all under 10, so its correlation is not the problem here. Okay, so the table 5 is the turnover rate and the performance. So we want to separate those companies with turnover or not. We have done that. And also we want to separate it's a forced turnover or it's a voluntary turnover. So this is the code to do that. So you see, so this variable tells it's a turnover or not. And if it's normal, we have 603 out of the sample. Out of the total sample, 2,107. Forced turnover is 71% among all of them, among all of the turnovers. So this is based on the data here by running table of this variable. And so after we do this, and we can define observations as forced turnover or voluntary turnover. And the next one is we want to, if you look at table 5, if you look at table 5 here, this is, yeah, table 5. If you look at table 5, so if you look at the table 5, so it shows the observations in the bottom quantile with the worst performance, and also it's comparing with the firms with the highest performance quantile. So you see performance spread between 5 and 1. So we need to separate the firms based on performance into 5 groups. So this is the following code was doing here. So quantile is the code here. So after doing this, so we separate all firms into 5 quantiles. So, and then it's only keeping quantile 1 and 5 here. So, because we're trying to get the differences of the 2 groups. And let's try this. Variable to force not found. Okay, I should try from the beginning. Okay, so you should start from here. Okay, yeah. So you see group 1 and group 5. So for the all firms data set, so you see the two groups, means and difference, all these statistic values are here. The difference, you see, statistic t-value is very high, so probability is very low. So there's a significant difference between the group 1 and group 5 based on performance. So this is running this part for all firms. And also we can cap here is capture, means capture here. So you can go to this website to get explanations for this variable. Capture is the cap is the shortcut of the capture. And then so this is the second one is to get the profit making firms. So so these kind of firms is if losses equals to 0, and that will be the profit making firms. And then also generate the quantiles for these five groups based on that. And so also compares them. Okay. Let's try this. Okay, the t statistic is not that high, but still significant. So this is part of table 5. For those companies is losing money, and we're doing something similarly. And also, so the difference between this one and the previous one is if loss equals to 0 for the profit-making firms. For the loss-making firms, is loss equals to 1. And then so, let's see, is there any, the difference should be less, right? Yeah, the difference are not so significant between the first group and the fifth group. The best performer and the worst performers. Group 5 is the best performer, and group 1 is the worst performer. The difference are not significantly different. But if we look at the whole group, and then so the significant differences are reported. So this is this one. So the results here, the table stat here is comparing the mean here, and this is a format with 3 digitals after the 3 numbers after the decimal here. So this tells the format of this number, the mean here. So this is just a t-test in Excel, in Stata. Okay, so this is table 5. So the next paragraph is if you run it, so you will get the table 5 directly. It's considered like optimizations of the results. Okay. Okay, so we don't need these. You can find the change tab 5.do file in the bottom of this code. It's here. You can copy it and save it, and under your status a do file folder, or you can save it under your status folder. So this is the tab 5. Yeah, this is a do file. It's on the bottom. Anyhow, so we can just, let's see. Yeah, see the results. Results is here. So it shows it was, you can just use it as part of as table 5. So it's just in the same format like table 5 here. Table 5. So this is table 5. So running that code will give us the results just like table 5. So anyhow, so you should add this change tab 5 chain added into this file here. But if you don't do this optimization, so you still get the results, but you may have to rearrange the numbers to make it similar to table 5 in that paper. Okay, so this is table 5. We didn't do tables 3. Okay, we did table 1, table 2, and now we did 4 and 5. Table 6 is it's a logic regression model. Okay, so you can find the logic model from the books listed in the class website. Okay, logic model is when you use this model when your dependent variable has only 2 choices, either something happened or not. In this case, there's a CEO turnover, and versus there's no CEO turnover. So so you have either 0 and 1 as your dependent variables. And because we know, like, if you want to use a linear model, and then you have to assume the variables has to follow normal distribution. But for the logic model, you can just have 2 numbers instead of continuous evenly distributed observations. So we can either use logic model or probic model here. Both are correct. You can use one in the paper and use another one as a robustness check. Okay, so anyhow, to run the regression, it's table 6. Let's find it. This should be table 6. Yeah, so table 7. Let's see, the dependent variable should be CEO turnover, and then those are control variables, and our main variable is just ROA, and then as robustness check, and so it's replaced by ROA and others. Okay, so let's since we got the data, it's ready to do the regression. So we want to get the log log of the age, so because age is not normal distribution. Okay, and then so this is just to find the variables here, and then so you can find the code to use logic model here. And then so this is to put the results as M1 here, and then we use IROA and all the other control variables and IROA in the second model here. This is result stored it over there. So change it to other independent variables. So we got more results here. And then so the results should be stored at in the results folder. It's called table 6 profit, this one. So this should be our, you should go to your results folder and you can find the results here. Let's run it. So yeah, so you can find it there. Like in mine, mine was here. Mine was here in results folder. So this is table 6 results. So you see it shows the coefficient and also shows the significant, and also shows t values and all these, and also it shows just like table 6. All we need from table 6 is here. Okay, so this is the, if you run this code here, so it will this is just because when the code when the code is too long, so it couldn't be written in one line, so we need another line, so you can add this, but you have to keep a space between, at least one space between this sign and the code here. And then so we can do the same thing, but for table 7, only do that for loss-making firms, making loss firms. And the result is it's the same. So results is in table 7. Results is table 7, and you can check it. It's working. So now what's left is table 8. You can compare the results, and so far with the results in the paper. The paper is using a different, using data in a different period. Ours is from year 2000 to year 2007. So also, there's one problem. We need to do some robustness test, and one way to do that is just to use the lag items, lag of the variables. But if you do so, you see the results doesn't hold, so it's not, the results are not so solid. Okay, so you can try other. So here it's just some hint and some concerns for this paper. And for table 8, now the next part is table 8. We're also using logic model. Oh, okay, no. The next part is just doing the same thing as before, but it saves spaces. It's using, like, let's say global command and local command, all these. So you just save those variables in some different areas. So, and also so you can call these areas and then run the regression. So it can save you some spaces. You don't have to repeat, like we've been repeating too much for different variables, and but you can save space by doing this from here to here. But if we don't need to do that, because it will give us the same results as before. It's just a different way to write the code. You see, they're all here. It's the same. Okay, so the next part, you can read the concerns of this paper. Anyhow, the last part is table 8, just like the paper. Now it's table 8. So you see it has some interactive terms between local and ROA variable. So it's same thing, but we just add some interactive variables here and then add it to the regression. So logic, dependent variable, and the independent variables for profit-making firms, for firms making loss, and we can try this. So it should just give us table 8. Yeah. Okay, so it said you can find it at results folder. Okay, so this is table 8. Now we don't need to do table 9. Table 9 is find the matching firms. The methodologies, you see, it's quite complicated. Let's don't do that part. So we have done table 6, 7, and 8, and those are the logic model results. And we also have done table 4 and 5, and table 3 is not needed. And we also have the results for table 1 and table 2. So after, this code is working, so if you click on this one, so we start from the very beginning. Well, anyhow, I just give you a simple explanations, or I'm just for this program. So if you have any questions, let me know. Thank you for watching. Have a good day.